Hello everyone, welcome to the Decodes. So in the last video, we have talked about that how we can create a single node in a linked list, right? So as we have said in the last video, that in this video we'll be seeing that how we can create a complete linked list with n node as well as how to traverse each and every node. So let's just see that. So today's topic is single linked list creation as well as traversal, right? So let's just have a quick recap about what we have done. But like if you haven't seen the last video or the last two videos yet, I would recommend you please watch that as well because it will clear a lot more concepts over there. So today I'll be continuing from there onwards because it is a chain of concepts, right? We'll be going one by one, right? So now see, let's have a quick recap and let's just understand what we have done so far. Say we have done this thing in the last video. We have talked about this thing rigorously. So what this thing is doing, these three lines, it is creating, as I have said, that to create a node, we need the help of structure. Why? Because if we only use int or float or any single data type, then we are unable to store multiple types or say multiple things together. But in a node, there are two things we need. That is, one is the data part as well as the next part. What is this next? Next is a pointer. And why do we need two things inside one node? Because here, in case of linked list, this is not contiguous. Just like array, it was contiguous. So if you know the memory location of the first element, we by default can calculate the memory location of the second element. But here you cannot do that because our node, back-to-back nodes are not having the same kind of location, right? This is the advantage of linked list over array, right? So in that case, inside one node, we need to store the address of the next node. So not only the value, but we need to store the address as well. So that's why with this particular node will be having two parts. One is the data part, another is the pointer part. So what this structure of the node is saying, that this single node will be having two parts. So if I see this diagrammatically, we will be seeing everything diagrammatically. So if you right now want to draw the diagram, we have done this in the last video as well. So if you want to draw the diagram of a node, so this is a node, we are trying to make a node. So this node is having two parts, one is data, another is next. So this is the data, and say next, right? And we have seen that this next, this is struct node star next. Just like for an example, we have written int star p, that is like p, that case p is a variable which is a pointer variable and which is of type integer. That's how we have read it, that's how we have said it. So in this case, if it is star next, that means what? Next is a variable which is a pointer, special variable. That means next will be holding some addresses. And whose address, which type of address will be holding? It will be holding the address of a node. That's why it is of type struct node. As simple as that. We have already talked about this thing. Now, if you want to see that how much space our node is occupying, how much space does a node need? So we have seen that for integer, suppose it is taking 4 bytes, though it is say what can I say infrastructure or say platform dependent or whatever it is you're going to say, right? This particular size of say integer. But for the time being, let us understand that it is having two things. One is this data part which is of type integer, another is say this pointer part. So suppose say this data is taking 4 bytes and this next is taking 8 bytes. So what is the total size of this particular node? 4 plus 8. The total size of this particular node is 12 bytes. This is the meaning of this thing. So I have done this thing so far, right? We have only said about a node. We have only talked about the structure of a node, right? Structure of a node, structure is what? It is a user defined data type. While we are combining, while we are kind of keeping all sorts of data type together inside it. It can have an int, you can even add some lines. For the time being, it is a single linked list. So it is having one say pointer. In case of a double linked list, whenever we will be seeing these videos, we will be seeing we need two pointers. One is the previous, that is it is holding the address of the next node. But in case of a double linked list, it will be holding the address of the previous node as well. So there it would be instead of one pointer, there will be two pointer. One is the previous, another is the next. So in that case, it would be int data struct node star prev, struct node star say next. So in that case, the size will be 4 plus 8 plus 8 because there are two pointers. So it will be 20. But for the time being, for the single linked list, this 12 is enough. So far we have talked about what is the structure of the node and say this is how this node is looking like. But we haven't created any node yet. We are just saying, we are just, defining that how the structure will look like, or this node structure will look like, right? Now after this, as we have talked about, there is a concept of head. What is head? Head is a pointer which is holding the starting address of the linked list, or say head is a pointer that is holding the first element's address of the linked list. Because yes, you can create a linked list of n nodes, but from where to start? Where to start the traversal? Right? This is from head. Right? So if you see this, we are trying to see that struct node star head. What is the meaning of it? Head is a pointer which is of type struct node. That means head will be holding the address of a node. That's what this thing is saying. But for the time being, we have said it is equals to null. Because we do not have any node yet. So far, we haven't done anything. We do not have any node yet. So head is holding null. And whenever something is holding null, that means what? That is the end of the linked list. So if head is holding null, that means there is nothing in the linked list. We haven't have any node yet. That is what it is specifying. Whenever something will be coming, say new node is coming, then that node's address will be kind of replacing this null value. And we can chain up with that head. We will be seeing this. So far so good. What we have done, say for an example, we have just specified how the node looks like, and we have created a head. For the timing, we have created a head, and we have said it is holding null. I'm just writing n shorthand so that it becomes easier, like, because we will be manipulating this thing, we will be changing the values so that it becomes easier, nothing else. So we are just writing n. So far we have done this much, and this thing is specified. Now step 1, because what is our goal? To create a complete linked list. So step 1 is create the first node. Obviously, we need to first create the first node. Now if you see what we are doing, we are first specifying struct node star first. What is this thing? We are saying that we want to create, we are kind of creating the first node. We are saying that there is something, there is a node that is coming and the name is first. Right? Simple. So whenever this thing is being done, that is what? It is saying that go to this thing and see for first what are the things we are needing. So if it is specifying that first will be looking something like this, right? This is specifying this thing. But as linked list is a dynamic data structure, so whenever a node is coming, we need to give some space. We need to make sure at that very time we are letting that node sit at a particular memory location with the exact number of space, say bytes or space needed. Right? So see the next line. It is saying first is equals to what this line will do. At the end of this line, it will be allocating the memory for the first node, for this first. So it is doing what? First equals to struct node star malloc size of struct node. What is this malloc? I have already talked. Malloc stands for M stands for memory, alloc stands for allocation. So allocate some memory for this first. You can read it in your mind like this. Allocate some memory for this first. And what amount of memory do you need? We need the memory. We need that much bytes, which is the size of struct node. Because it is a node, because this first is a node, so we need that much memory that a node is needing. So we need to go to the structure of the node and we need to see what is the size. So we need to go here and we will be checking that each node is having 4 byte plus 8 byte is 12 byte. So this thing will be coming up with 12. So it will be saying that allocate memory of 12 bytes for fast. Right? I hope it is understood. Right? So whenever this will be allocated, it will be reading it from the right side onwards. Whenever it is done, so this thing will do what? It will be allocating memory of 12 bytes for fast. Simple. Now what is the role of struct node star? This struct node star, this particular malloc by default returns a void pointer, and this struct node star is nothing but typecasting. So we are trying to typecast that void pointer and we are saying that it would be of type struct node star. Right? We are just converting, nothing fancy. But for the timing, what this exactly line is doing, it is giving 12 byte of memory to the first node, because that is the memory needed for one individual node. I hope it is understood. Then we are just simply typecasting from void star to struct node star. As simple as that. So whenever this line is done, what we have? We have our first node. we have our first node and it has allocated 12 bytes of memory. So whenever it has seen that it is of struct node star fast, so it has seen that there are two parts. So one is data part, another is next part, and the overall total memory is 12 bytes. So this particular part is 12 bytes. So this is the thing that has been done so far, nothing else. It is looking like this so far, right? Now if you go to the next line, say whenever this fast equals to something we have done and 12 bytes has been allocated, so it has been allocated from some memory location. For an example, if a guest is arriving or if a particular person is arriving at a hotel, that particular manager is giving him some, say, key to some room. There might be 50 rooms available, but he will be giving only one key to that particular person, said go to room number 205. Same way, it will be giving 12 bytes, but at a certain memory location where it has available space. Suppose say it is giving from 1200. So from 1200, say this 12 bytes is from 1200 to 1211, because if you see this is 12 bytes, right? So it is giving, I am just considering the first address, that is 1200, right? The starting address. Now it has given to this memory location. Now what we will do, next thing, fast arrow data equals to 10. So what is fast? Fast is a node, and what is the address of fast? 1200. This is the address of fast, right? And how much bytes does this fast is having? 12 bytes. Make it clear in your mind. Now it is saying go to fast, and fast has two parts, because first is the node, one is the data part and this is the next part, that is data part, integer part and pointer part. So it is saying go to fast, and in the data part put 10. So simply it is saying go to memory location 1200, and there are two parts, data and pointer. In the data part you place 10. This is the meaning of this line. Now in the next thing it is doing fast arrow next equals to null. That means what? This is the next part which was not having anything so far. Now we are putting null over here. So go to this memory location. What is the memory location of fast? 1200. Go to this memory location, and in the next you put null. We have done. That's how diagrammatically we are going ahead so far. Now see, there was a head. Head was holding null. Now we have created a fast which is having some data, and we have put null in the next, that is in the pointer part. Now to make sure that these two are connected, because now we need to make sure that this null should be replaced, else how do it disconnect? And what we have said, whenever the fast node is coming, this null will be replaced by the memory location of fast. And what is the memory location of fast? 1200. So how to do that? If you see the next line, head equals to, head was initially null, now head is equals to fast. What is the value of fast? 1200. So this null is getting replaced by simply 1200. So whenever this null is getting replaced by 1200, it will be saying that head is pointing to 1200. That means head is holding this particular node. Head is holding the address of this particular node. So from head, it will be coming here. So we have created a linked list with a single node. Now see, head is having some value. So it can trace back or it can traverse to here, and this fast node is having null as the pointer. That means what? The fast node is not holding anything. Whenever you are seeing a null in a particular, say, node, it is simply saying this is the end of the linked list. So we have only one node so far. But what will we be doing? We'll be creating chain of nodes, right? So what is the next step? Now step 2, create the second node. See, now you have understood everything. It will become absolute easy peasy cakewalk for you. It is absolutely easy now. See, struct node star second. You know what is this thing doing? It is absolutely the replica. Struct node star fast. So what this struct node star second is doing? It is creating a node. Just like a second node. It is like this. Right? Now what it is saying? Second equals to struct node star malloc size of struct node. What it will do? It will go here. It will be finding the size of the struct node. Same line. Same to same line. It will be saying 12, so it will be allocating 12 bytes, and it will be saying there are 2 points, there are 2 things, data and next, so it will be creating like this, and this will be total 12 bytes. And it will be giving at some memory location, say the memory location of second is, suppose 7500, because it is not contiguous, it can be anything. If it is 1200, it need not be 1212, it can be anything, so it is 7500, right? This thing is done, this thing is done. Now, if you see the next line, second arrow data equals to 20, right? So we are creating here. Let not create here. So let's just create here. So this is second. This is say second. right? And the memory location I have said is 7500. And now it will do what? These two lines are done. It will go here and it will say second arrow data equals to 20. So it will be giving 20. And second arrow next equals to null. So this particular portion is null. Right? So that means what? Up to this part, what you have done? We have created a node. We have created the second node, but we haven't connected yet because it is not connected. If you see this part is connected, there is a link, but it is not connected yet. To connect, what do we need to do? Now you already have understood, I guess. We need to make sure that this null of the first node will be replaced by the address of the second node. If we can do that, if we can give the address of this node here, that means it is saying that after this, go to this memory location. So it will be connected. Correct? So that's what exactly we are doing. First arrow next was initially null. First arrow next was initially null. So this first arrow next will be replaced by second. What is the meaning of second? Second is nothing but the starting address of the second node. What is the starting address of the second node? 7500. So this null is getting replaced by 7500. So whenever you are saying 7500, there is a link. There is a link. So what is the meaning? This node, the first node is holding 7500. What is 7500? 7500 is nothing but the address or the memory location of this second node. So it is saying that go to this and you find this. Now see, now we haven't written anything. We have just created two nodes comfortably. Now to create third node, you can easy peasy do that. What do you need to do? You need to write struct node start. Instead of second, you will be writing here third. Right? So whenever you are creating third, again, what will you do? It will be creating a third node. Say at memory location 1111, suppose. Right? At this location. Now, instead of second, here again you will be writing third. So you are not writing second anymore, you are writing third. Right? So it would be giving memory location, it will be saying 12 bytes to this third. Right? This would be of 12 bytes. 12 bytes. Now, this would be instead of second arrow data, you will be writing third arrow data. So say for example, let's do it here again. It becomes comfortable. So it would be third, the memory location I have said is 1111. Now third arrow data is 20. So third arrow data will be 20. Now say third arrow data say 30. It will be 30. 20 is already there. So let's just take another value. It can be 20, no problem. But third arrow data say 30. Right? Now again third arrow next, it will be third. So initially the third arrow next will be null. So it would be null, right? And now what we need to do? Now to connect with after this node, we need to change this value. So second arrow next was null. Now third arrow next is null. So it would be second arrow next. Second arrow next. It would be second arrow next because we need to change this value. This was second. Second arrow next is supposed to be the memory location of this one. So what is that? It would be third. Second arrow next equals to third. So what is the value of third? 1111. So this null will be getting replaced by 1111. So this will be connected. Similarly, if you want to create another node, what do you need to do? Just do fourth. Again here fourth. Here fourth. It would be say 40. It would be say again fourth. And this would be third arrow next is equals to fourth. So suppose say the fourth one is say here. It is say the memory location say 5000 and say it is fourth, right? So it is giving 40, so give 40 and fourth arrow next is null, so it would be null and this third arrow next is getting replaced by fourth. Third arrow next is getting replaced by fourth. What is the value of fourth? 5000. So this null will be replaced by 5000. It is connected. That's how you can connect each and every node. Now it is easy peasy. You can connect n number of nodes easily. I hope you have understood everything. Right? That how to create this entire linked list. This is how it is creating. This is how it is done. 12 bytes for each node. Each node is having some memory location. Whatever be the memory location of that node, that should be in the previous node's address part. Easy peasy. If you see this below part, it is the memory location of this node. And simply the diagram should look like this value and this value should be same because this memory location should be in the previous node's address part. Similarly, this. Head is holding the address of the first element. If there is any null, that is the end of the linked list. So that is how we can make. If you want to create 5th, 6th, 7th, you can do it. No issues. So we'll be doing line by line. This is the first line, second line, third line, fourth line, 5th, 6th, 7th, 8th. 9, 10, 11, 12. Then after creating this as a second, I have just cross it out. So after second, you can write for the third. After third, you can write for the fourth, and the whole code will be constructed. So that's how we have created the entire linked list, and that's how you can proceed up to n nodes. Right? So this is the linked list creation part. So it is done, and I hope that whatever we have talked about, you have understood everything. Right? Now how to traverse? Now the question is how to traverse. So the traversal part. See, we can traverse using head. That's what I am saying. That head is holding the address of the first element, address of the first, say, location. So in that case, we can start traversing using head. So head arrow data will be giving 10. But because head is really important, head is actually holding the most important data, so we will not risk using head, because there might be a little bit of data manipulation, and that time that if head is lost, and we will be in huge trouble. So what we will do instead, we will create another pointer, that is struct node start temp. That is a temporary pointer that will be used only to make sure that we are using the value of head, or you are trying to copy the value of head inside that. That will be used as a kind of pseudo head. How? See, struct node start temp. What it is saying? Temp is a pointer, just like we have written struct node start head. Similarly, here writing struct node start temp. Temp is a pointer which will be holding the address of a node. Now we are copying the value of head to temp. So what is the value of head? 1200. So temp will be holding here 1200. Right? So temp is holding here, temp is equals to 1200 here. Right? So we have copied the value of head. We are not working with head directly. You can work with head, but that becomes sometimes risky. What if something you do with the head and everything get lost? Because if head is lost, everything, the whole linked list will be lost. We do not want to take that risk, right? Now what we are doing, while temp not equals to null, how much we will be traversing? We will be traversing until we reach this null. Because null means this is the end of the linked list. We cannot traverse further. Correct? So we will be traversing until the temp becomes null. While temp not equals to null, we will be trying to print that. So how we are doing? See, in the first thing, temp is 1200. So this condition is satisfied while temp is not equals to null, because temp is not null. When temp will be null? Temp will be null if there is no node at all. Right? In the first place, struct node star head was equals to null. So if it was no node, after creating one node, head has some value. So if there was no node, up to this part, head was null. So in that case, temp was null. So in that case, temp arrow next, this condition was not satisfying. So that would have stopped there, because there is nothing to print. We have no node. But here we have some value. Head has 1200. So temp will be having 1200. So it is saying while temp not equals to null. Cool, because temp is having 1200. Printf percentage %d. Look, we are giving percentage %d, not percentage %p. Because what we are trying to print? We are trying to print these values. We are trying to print these values. And what are these values? These are of type integer. That's why we are using the access specifier percentage %d. Right? So what will we be doing? Printf percentage %d temp arrow data. So what we will do? Temp is 1200. So go to 1200 location. And because 1200 location has two parts, one is the data part and another is the next part. So just give me the data. So what is temp arrow data? 1200 arrow data. What is 1200 arrow data? Go to 1200 location and data part is 10. So it would be 10. First it would be 10. First 10 will be printed. What is the output? This percentage %d will print 10. Right? Then inside this loop only we are doing temp equals to temp arrow next. So what is temp arrow next? Temp is 1200. How to calculate this thing? Go to this memory location. And this is the data part. If this is the data part, what is the next part? 7500. So temp becomes 7500. Cool. Now again, while temp not equals to null, temp not equals to null because temp is having 7500. So you go here, printf percentage %d temp arrow data, who is 750. So that means go to 7500 location and give me data. That is this 20. So 20 will be printed. And temp is equals to temp arrow next. So temp is equals to temp was 7500. Now it is getting replaced by temp arrow next. So we are at 7500. Where does next? 1111. It will be replaced by 1111. Similarly, next time it is saying again temp not equals to null, satisfied. So printf temp arrow data. So go to 1111 and see me the data part. So what is that? That is nothing but 30. 30. Right? Then again temp equals to temp arrow next. So who is temp arrow next? In 1111, what is the next part? 5000. So this is getting replaced by 5,000. So go to 5,000 and print a percentage D, temp arrow data. So go to 5,000 and give me the data. What is the data? 40. 40. Now temp equals to temp arrow next. So who is at temp arrow next? We are at 5,000. Right now temp is 5,000. 5,000's next part is holding null. So temp will be replaced by null. Null. Temp will be replaced by null. Now while temp not equals to null, will not be satisfied because obviously there is no more nodes. What to print? There is nothing. So it will come out. So that is the end of it. So that's how we can traverse it, and after traversing this is the output, because exactly that's the thing. You can see 10, 20, 30, 40. Right? In case of array it was stored in contiguous location. In case of linked list it is not stored in contiguous location. The next node's address is stored in the previous node. As simple as that, and that's how we can traverse. That is the whole code for traversal. Right? And after traversing, this is the output we have got. That is exactly correct, as you can see. And that's how the temp is being changed after one while loop iteration. Right? So that is the way we can traverse. So far we have seen this whole thing, that is single list creation as well as traversal. So I hope that whatever we have talked about so far, it is absolutely clear to you all, because I have tried to break down everything for you. Right? Now the last part, that is what is the time complexity. If you see, to traverse all the nodes of a linked list, we have traversed the entire list. So if there are n nodes, if there are 4 nodes, so we have traversed 1, 2, 3, 4 like that. So if there are n nodes, we are almost traversing n times. Right? We are almost seeing all the n nodes. So what is the time complexity? Order of n. So the time complexity for traversing in case of, say, linked list is order of n. Right? So in this video, we have seen how to create a linked list and how to traverse it. That is the first basic operation of this particular linked list. We have seen in case of array as well, several other operations. So in this video, we have seen the first operation of linked list, that is traversal. And in the coming videos, we will be seeing the operations like insertion and deletion. So I hope whatever we have talked about in this video made sense to you. So thank you for watching and stay tuned for the next videos.